I work for a company called Ironhack. This is their shirt. That's why I'm wearing it. Today we're going to talk about the present and future of JavaScript. You need this. So first, please feel free to interrupt me with questions. As an extra incentive, anyone who asks me a question gets a Heath bar. If you have not ever had a Heath bar in your life, ask a question. You're missing out. Okay? That is a question. Here, find out for yourself. Okay. I interrupt you with the questions. These are delicious. They're chocolate. Anyway, so I've got 6 parts for you today. The second of which is a doozy, but aside from that, they're going to be pretty straightforward. So today we're going to talk about the present JavaScript, right? So that's part 1. So I said I'm here to talk to you about JavaScript, that's fine, but rather really what we're going to be talking about is not necessarily the language, even though we're going to mention that. We're going to talk about the spec, the specification of the language, the standard, if you will. Okay? There's a lot of interesting things going on. So the first part of my talk is actually doesn't have anything to do with code. I just want to give you an idea of what's going on in the world of JavaScript and why I'm excited about it. So the spec, in the spec, the language is actually called ECMAScript, not JavaScript. It's because the standard is organized by the ECMA people, and they have a bunch of different standards under their wing. And so really it's called ECMAScript. And the spec itself is called ECMA 262. I don't say this so you remember this, because I don't remember this. I have to look it up every time, but just so you know that there's a bunch of different ECMA-related things going on here. And the latest version of ECMAScript is actually the 6th edition, colloquially known as ES6. ES for ECMAScript, and 6 for the 6th edition. So that's really what we're going to talk about today. So this specification, this standard was finalized in 2015, and thus its official name was changed to ES2015 rather than ES6. Even though I'm going to jump back and forth, most people still call it ES6 because they kind of did that name change later on in the process, but that's fine. This year, the year 2016, ES6 2016 will be finalized, but more on that later. So last year, ES6, aka ES2015, and this year, ES2016 is coming out. But ES6 is much more than a bunch of new language features, which we will get to, don't worry, and Jeremy was kind enough to go over some beforehand. But it's a lot more than that. It represents a lot more than that. It's a sign of a huge swing in momentum for JavaScript and for the web. And that's what I want to instill on you. If you take away anything from this talk, I want it to be this, that JavaScript has a lot of momentum right now. Okay. So it's really important to understand how we got here to really understand why it's important that momentum is important. So we're going to talk about the past. This is the longer section of my talk, but hopefully you'll find it interesting. So the past, what happened? How did we get here? How did JavaScript start anyway? Well, JavaScript was first developed in 10 days in 1995 by a man named Brandon Ike. Many of you probably know him. He was the CEO of Mozilla for a while. Until then, he wasn't. So he developed that in 10 days. 10 days! I mean, in the last 10 days, I didn't get anything nearly as productive done. I don't know about you. Anyway. 10 days, that's crazy. Needless to say, it wasn't perfect, right? It had its defects. He was in a hurry, okay? He didn't have time to quite do things maybe the way he wanted to do them. In fact, some of those imperfections are still in the language today. This is 20 years later. So why? Why didn't they fix those across 20 years? Well, at some point it was decided that JavaScript should remain backwards compatible. And the same is true for CSS and the same is true for HTML. The languages of the web need to retain their backwards compatibility, which is to say that JavaScript from websites that were made 15 years ago should still work today on modern browsers. So if you go to a 15-year-old website, it will still work because all browsers maintain backwards compatibility of JavaScript, HTML, and CSS. It will still work the crazy, wacky way it used to work 15 years ago. So that's why it still has some of those quirks, because to make JavaScript better, new things have to be added without breaking the old things. And even though the old things were stupid, like for example, how many here have used the date object in JavaScript, the date class? Okay, most of you. So who can tell me something weird about the date class? Yeah?
Monster zero index.
Yeah, monster zero index here. Let's see if I can reach. Close.
Close.
Very close. All right. Monster zero index. That means that January is not month number 1, it's month number 0. What? That still has how it works today. Because we can't break that, because maybe a website 15 years ago was counting on the fact that January was month 0. Who knows, right? We don't want to break that website from 15 years ago, so we have to improve JavaScript by adding new things without breaking the old ones. So the first ECMAScript standard was finalized in 1997. That's 2 years later. Brandon Knight made this thing in 1995. I think Netscape launched it publicly in 1996. Then everyone was like, okay, this thing is pretty cool, but let's not like let Netscape go crazy with this. Let's like everybody work together and like make a standard and actually make this like an official thing. So they did that in 1997. That's ES1. Here you go. ES2 was finished in 1998, a year later, mostly with editorial changes. That means that no new features, okay? So, made in 1995, standardized in 1997. A new version of the standard was drafted in 1998. And ES3 was finished in 1999, and that added a bunch of new features. That really kind of rounded out the language. For example, they added a really important feature called, like regex. That was added in ES3. I can't think of anyone else. That's the one that stands out the most to me, but that's kind of the main feature. One of the main, like that's the kind of thing that they were adding. They were just making sure that JavaScript was a full and complete language, even though it had weird things in it. So that happened in 1999. They finalized that standard, and it actually ES3 is kind of when I started learning JavaScript. ES3 is what I learned. But here's where things start getting bad. When I learned JavaScript, when I was first learning, ES3 was already 10 years old. And that's the one I was learning. What gives? What happened? JavaScript created in 1995. ES1 finalized in 1997. ES2 finalized in 1999. ES3 finalized in 1999. And then what happened to that momentum? What happened to that boom, boom, boom of every year getting something done? That went away. So remember ES4? It had a milestone in 2007. Can anyone know that milestone? Well, first 2007, that's a lot of years, right? 1999, I can do math, that's 8 years. That's a lot of years. That's not 1 year. That's way more than 1 year. 8 times as many years as before. So first of all, that's right there off the bat is weird. And the milestone was that they were working on it and they abandoned it. They scrapped it in 2007. Okay? So after 8 years, they ended up with nothing. And no one ever used, well, maybe somebody did, but I never used ES4 because it never came out. They just abandoned it. The committee, TC39, Technical Committee 39, couldn't agree on what you do and what ES4 should do. And apparently, ES4 wanted to do some pretty crazy things. If you look at the list of features on Wikipedia, you can see some of them. But you know, some of that stuff was used in later versions, so it's not like completely crazy. But no one could agree on what exactly it should have. The changes were too big. It was too sweeping a change. Okay. I think they wanted to break backwards compatibility in ES4. It's one of the points of contention there. Anyway, so the TC39 went back to the drawing board and they began work on ES5. As soon as they scrapped ES4, they took some of those ideas and started working this from scratch. So like, forget ES4, that's dead now. Let's work on this new thing. That came out in 2009. This is more or less around the time when I started JavaScripting like an adult, like a serious person. But that's 10 years between ES3 and ES5. That's 10 years between new versions. And when I learned, that's more or less the time when I started learning, and that's 10 years. Like, what gives? That also coincided with what I call the dark age of the web. Okay, we'll get into that in a second. But anyway, new features in ES5, like they were there, but I couldn't use them. We couldn't use them. Why not? This is where the dark age part comes in, right? It's time for a little bit of public shaming, okay? Just a little bit of bullying. Can't hurt anybody. So how many here know somebody who never updates their computer? How many people here are the person that never updated their computer? Okay, got one honest person. The rest of you are liars. Okay? I haven't updated my computer. My Chrome, I never restarted it anyway. So some of you are liars, at least some. Okay. So we couldn't use ES5 when it came up because of people like them and people like me now. It wasn't always this way. It's a problem. I know it's a problem. And so we couldn't use ES5 features because people like that, they never update their computers. Like, because people in China are using Internet Explorer 7 forever, that we couldn't use ES5 features because Internet Explorer 7 doesn't have those features. Internet Explorer 7 is still living in ES3 land. It's still living in the year 1999, even though, I don't know when it came out, but it was certainly was 1999. Like, come on guys, what are you doing? Get in the game, Microsoft, you know, at that time anyway. It's because of those people that we couldn't, like, sure, the stuff was happening, but like, it didn't matter. Like, I still had to write ES3 JavaScript because browsers, that's what browsers had. But now, you know, modern browsers update themselves in spite of users like me now and other people. They update themselves. Like, every time you restart Chrome, you don't know it, but hey, it's updating. Firefox updates itself. Safari updates itself when you do like a system update that you should probably do anyway. And it can be configured to update itself. I don't know what the story is with Windows, but I'm sure that has a way of updating itself. So now they just do that in spite of you. Doesn't matter what you do, they're going to update. So now we get, as soon as the browsers implement the new features, we get them delivered to our computers. Old Internet Explorer is mostly gone. Microsoft did, to their credit, did clean up their act with their later browsers. It's not as bad as before. Someone's taking a picture, and are you going to tweet this at somebody? Oh boy. So that brings us back to the present. ES6 in 2015, I can still do math, that's 6 years. 6 years between ES5 and ES6. Now, basically you can use ES5, most browsers will have that. There's still IE9 running around there, so IE9 definitely doesn't have new features. It has ES5, that's fine, it's fine. I'll deal with that. I'm good on that. So that brings us to the future. So what's happening from here on out? So from here on out, so how long again was how long between ES6 and the next one? I said that before? A year. 1 year. We're back to the beginnings of JavaScript. We're like boom, 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 every 1 year, 1 year, 1 year. In fact, that's the motivation behind that renaming, that rebranding of JavaScript to be from ES6 to ES2015. It's like they are committed to doing this. ES6 is now ES2015. What used to be ES7, we should all start calling it ES2016 before ES7 catches on. And then ES2017 was never even called ES8.
Where did you get the release 6? I was like 16, 17, 7.
So the TC39 has committed to the new JavaScript every year. New JavaScript features every single year. That standard is gonna be updated every year. That puts pressures on browsers to implement the features faster, and that's kind of what Microsoft has been doing. They're saying, whoa, like everybody hates us now. Let's like do something. Let's try to improve our image. Hey, what can we do? Maybe we can implement some ES6 features. Maybe we can suggest even some new features. Maybe we can do things like that. Hey, we can do a little more open source stuff. Maybe do TypeScript and push that and try to get those open source people to like us more. So that's a valid differentiator. If there's only one browser that has all of ES2016 features, developers are going to gravitate towards that browser, right? That's a meaningful differentiator between the browsers, right? Which right now, what are the major differences? Like, it's hard to tell. Aside from that one is called Chrome, the other is called Firefox and is red, and Chrome is yellow, and Internet Explorer is blue, I think. Whatever. Anyway, it's working. Browsers already have most of the ES2015 features. They even have some ES2016 features right now, right today. So the future of JavaScript is really exciting. Every year, new JavaScript. Browsers are pressured into actually implementing that. So from a 10-year gap, we're going to yearly releases again. Yearly. That blows my mind. So that brings us back again from the future to the present. So what does that mean for us that we're writing JavaScript every day? That means that today the TC39 is comprised of a bunch of awesome people. They represent a bunch of really cool companies, including the people who make browsers and jQuery Foundation, etc. And people who are making applications, really awesome applications like Netflix. These people are pushing the standard forward. There's browser vendors, people who make browsers, but also developers, people who make applications that have real wants and needs that we all have. They draft features with the community, and the browsers implement them. it's not just some guys in a silver, you know, on a white tower somewhere with their really long beards going like, what should we do with JavaScript today? No, it's everybody together. All this stuff is happening in the open. You can see all the communication that TC39 is doing. I'll have a link to that at the end of the talk. So a bunch of different resources that you can do to keep your pulse on what's going on. It's working. And you know, different browsers have different priorities, so they implement different features, and that's on them, right? They all have their own release schedule, and they all have their own different sets of features they want to implement first. They have different ones that they think are more important than others. And so, yeah, there's still going to be differences. Like, eventually, you can assume ES6 support in all browsers, but not today. In the meantime, we can write modern JavaScript, but unlike 2009 when I was learning, where we couldn't do anything, today we can write modern JavaScript. How can we do that? We can use tools to compile the JavaScript of tomorrow into the JavaScript of today. One such tool is Babel. So Babel is a transpiler. It takes ES2016 JavaScript or whatever, the newest JavaScript, and translates that into JavaScript that's compatible with browsers. So before I say that Babel tools will never go away, I'll show you kind of what this is. So here, Babel actually has a REPL that you can use to translate ES6 features live. So let's, for example, we can do the class syntax. Class, let's do pizza. Okay. Okay, so pizza is going to have a constructor. That constructor is going to receive the kind of sauce, kind of crust, and a list of ingredients. Toppings. Okay. So all this stuff on the left, I'm writing ES6 JavaScript. On the right, I'm getting browser-compatible JavaScript. And now they're defining this function called class call check, and that does a bunch of weird things that makes my classes work. But this, if I run this part on the right, if I run this in Chrome today, it'll work. If I run this in any browser today, it'll work. If I run this in Internet Explorer, it'll still work. Now, obviously, you're not going to go to a website and do this manually, right? This tool is available on the command line. It's available live in your editor. There's a bunch of different ways that you can integrate with this thing. And there are other tools too. It's not the only one. The point is that you can write the JavaScript tomorrow anytime, and with this thing, you can compile it to whatever the browsers are running. And our real web applications already has tools anyway to concatenate your JavaScript, to make sure that remove all the white space and make things more efficient like that. So you have the tools anyway. So it's not adding an extra step to your process. So I'll link to this later on. I'll also be deconstructing some of these features that I'm doing here. My point being is that these tools are not going away because they'll allow us to always write the JavaScript tomorrow, no matter what year it is. So this year is 2016, so we can write ES2016 today because of tools like this. But 3 years from now, when ES2016, we can assume that all browsers have it, we're going to be able to compile ES2019. I had to do that now. ES2019 JavaScript in 2019 because of these tools. So they're always, every time a new feature is added, these guys are adding it to their tools. And this is an open source project. Anyone can come in and contribute and help out with this too. The guy who made this is a genius. He's like 17 years old, and he got a job at Facebook. Yeah. Just saying. Okay, so now let's actually talk about code. Let's actually talk about the features. So a couple I'm gonna point out today in particular. There's many more than this, but we're gonna talk about these one by one. So the spread operator, error functions, template literals, class syntax, etc., etc. Let's go start with the spread operator. Okay. Is anyone familiar with these already? Okay, maybe 10%, 50%. Or the rest of you are too lazy to raise your hand. Either one. I'm not judging. Okay, so spread operator. I'm actually going to go into my node REPL. Because I want you to be able to see the result of running the code, not just like the result of the compilation. So Node uses V8 as its JavaScript running engine. V8 is really what powers Chrome behind the scenes. So Chrome actually has a lot of these, I think most of, if not all these features that I've listed, has them today. So your latest Chrome and your latest Node.js will also have all these features. So the spread operator, okay. So basically the spread operator is ... And you use that with something like an array. I say like an array because it can be an array, but it can also not be an array. So here's what I mean. So let's say I have an array. We did toppings earlier, so let's do toppings. Toppings equals, so what do we want on our pizza? Pepperoni. Okay. Two ends. What else? That's it.
Meatballs.
Meatballs. What did you say over there?
Cheese.
Cheese, definitely cheese. What kind of cheese? Mozzarella? You're a purist? You name it, okay. So wait, let me hand out these candies before I forget. Who said meatballs? Boom. Cheese? Boom. They're very light, they won't hurt. Okay, not bad, not bad there. All right, so I've got an array here. Now, the idea behind the spread operator is that anywhere I would have like these values separated by commas, I could use the spread operator to turn that array into like the comma version of that. Okay, that's confusing, but so for example, I can make a new array. I can say more toppings equals, let's add some more crazy features like pineapple. And do ham. So here I'm going to do ... toppings. And so that's like taking all of the toppings in the toppings array and just putting them separated by commas inside that state. So it's going to concatenate them implicitly. So let's add some more features at the end here so we can see bison. Bison is good. Okay. So that's the array. So this, first of all, the spread operator can help you with array concatenation a lot easier because you don't have to make so many copies of the array. Right now you have to do array.concat, and array.concat returns a new array, but then if the other thing is not an array, you have to do a lot of finagling to make it work. This is a lot simpler. This is a lot simpler. Another reason you can use the spread operator is instead of having to do array function.apply. Who's done function.apply before? Okay, like 30% of you. So function.apply means that, okay, I have this array of arguments, and I want to send that array of arguments to a function as if it was a comma separated value. So like I want to do something like this, where I'm doing console.log, and then first thing, second thing, third thing. But I don't want to send the array as it is. I want to send like this. I want to send the values as my arguments of the function. So I can just put in my spread operator in toppings here. So ... toppings, and it's as if I just printed console log pepperoni, comma meatballs, comma mozzarella. Just applies those arguments automatically. Another use of the spread operator, you saw me use it earlier, is when you're defining a function. Function toss pizza. And this doesn't make any sense. But anyway, instead of having to do arguments, like you usually used to when you're doing a variable amount of arguments in a function, you can put this spread operator inside the function arguments, and it's going to be an array of whatever arguments you send it. So let's say I'm going to console log. Let's do a loop over those. So let's do toppings for each. Error function, which I'll get to later. And then I'm going to return, I'm going to do console log. Stop. Console log top. Okay. I think that should be good. Close that. Oh, I'm missing something. What did I miss? What did I miss? It's not closing. Probably. to that function. No, doing something wrong. If in battle, I could probably do this. See what that does. Without these things here. All right. So look what it's doing on the right here. So on the right, it's saying, okay, it's going to iterate through arguments and assign to this toppings variable all the arguments inside the arguments object. So this is basically a much more concise way of doing arguments, because arguments, if you remember correctly, it's not really an array. It's something like an array. It has length. It has a square bracket syntax, but it doesn't. You can't do for each on that thing. You have to do. You used to have to do a hack like do something like arguments array dot prototype dot slice dot call and give arguments as the first argument. Some craziness like this, and this would be your toppings. Well, you don't have to do that anymore. It doesn't work because I'm not in the function. With just the spread operator, pass in the ... toppings, boom, you're good to go. That apparently is not working in Chrome quite yet. So that's the spread operator. Anywhere you would have a comma separated values, you can replace that with ... in an array, and it just applies those array members in there. Another thing I want to point out is arrow functions. Jeremy already mentioned this, but I'll mention it again. So arrow functions does a couple of cool things. The coolest thing it does is that it makes it so you don't have to worry about the value of this anymore. This is going to be this wherever you start calling your function. So it doesn't do anything weird with that. So if I have an object like a pizza that I want to eat, say I'm going to have an argument with that that's going to be called eat, which is a function. So in here, let's screw this up. So in here I'm going to say, okay, I want to call this toppings for each. And so in this for each, I can do something like console log this dot name. If you named your pizza or something, or this dot order person. So aside from conserving the value of this, another thing that it does is that it has what we call implicit return. So an implicit return means that you don't actually have to give you the return keyword when you're returning something. So another use of functions is often like if you have an array of toppings, like we did before, let's get that back. Not this one. Wait. If I wanted to map that function, that array, I would do something like, and then usually you have to return the new value, right? You have to do something like return top dot to uppercase is what I want to do this time. But with arrow functions, you actually don't have to do the return. So you can get a much more concise function. You can do something like this. Toppings.map top arrow function, and then whatever value is calculated gets returned to map. If I do this, I get pepperoni meatballs mozzarella without having to do return. Now there's some quirks to that. The quirks are if you want to return an object, then you've got problems. Like if I wanted to return something like this, where I'd have uppercase and top dot to uppercase. And original top. I couldn't do that. I have to put that in parentheses. Because otherwise it treats that as if it was the curly braces of the function itself. So there's some quirks to that. Those perks you can see, and I'll post resources about all these. So I'm going to post my slides, and these are actually links to articles with details about each of these features. And so all those perks are mentioned in those really thorough articles. So unless you're returning an object, arrow functions are really an amazing tool to use because you can write much more concise JavaScript. Now, the issue is that it might take some getting used to because you might look at an arrow function and be like, whoa, what's that? You know, especially if you're not used to other languages that might have that fat arrow or that hash rocket, as it's called in Ruby. But you know, once you kind of see the use of it and how concise your code can be, it's actually quite a blessing. It saves you a lot of that wordiness of the function. And that implicit return, like removing the word function, removing the word return, that is actually a really good saving in terms of signal versus noise. Because if you're just going to see a lot of keywords, it's a lot of noise, and you have to really look at the function and really process it to be able to internalize what it's actually trying to do. So that's arrow functions. Hear that? Another thing that Jerry mentioned was template literals. I'm going to do that really briefly, but these are really awesome, especially when you're trying to concatenate a bunch of HTML. Note here. So if I wanted to have a really long, like I'm really having an li here, and then that li is going to have an h3 in there. Maybe there's a paragraph in here. This is a paragraph. And you're closing the line. That is actually evaluated as a string, even though you use backticks instead of the quotations to do that. So this is a really good example of how JavaScript is adding new features without breaking the old. So to add things like multi-line strings and string interpolation, like Jeremy said later, so if I have a variable like this one, name equals name, and then I do a big string interpolation, except instead of this, I do $name. It's capable of pulling that in. See how I replace that with Nazar? To do that, you wouldn't be able to do something like this in an old string because that would break backwards compatibility. Because what if somebody literally wants to have a $sign in a curly brace and that would break their code? So to work around that, we have this new string, this new kind of string, which is using the backtick. So for reference, the backtick is going to be on the left of your number 1 key. So they're doing crazy stuff with this backtick string, and they're leaving the old strings just as they were. So they can still retain backwards compatibility, but adding new, really nice extra features like this one. So multi-line strings and string interpolation, really, really cool. No more crazy concatenation, no more adding a bunch of strings to an array and then joining the array. I don't know if you've seen that, but that kind of craziness is over with. Okay, what else? We've also got the class syntax that I showed off. Before the class syntax, I actually want to show off object literals. So there's actually new features for object literals as well. Let me pull up that one here. So if I do, like, so I don't know if this happened to you, but like oftentimes I want to debug. I want to do a console log for debugging, and I have like 4 different values that I want to print out. So what will I do? I'll do something like console log, the name, and then the variable name, and then console log, last name, and then the variable last name. I used to do that. But actually, with new object literals, if I have a variable name, and a variable last name, say I have another variable called city or something like that, I can actually do something like this. Object, name, last name, city. that'll give me an object with the key of the same name as the variable, and then the value of the variable. Key is the same name as the variable, and value is the variable. So that really makes it a really good shorthand for making these objects that are just values of variables. So this kind of syntax you can also do in object literals. You can also, when you're building out an object, if you want it to have like a dot or something here, like maybe you have something weird in your key, like you have to open a string like that, and then this will be the value. But what if you wanted to put the value of a variable inside here? You couldn't do it. You'd have to make an empty object and then use the square brackets to assign the object like this. You have to do like, okay, var object equals that, and then object name, put a variable in there, and then give that the value or whatever. Now you can do that with an object literal. You can open square brackets and then put the value of a variable in there. And then that key will take on the value of the variable, not literally named. So that can be useful sometimes as well. Now, you can't mix those both. You can't do something like this. That won't fly. So that's, again, one of the quirks of this new syntax. But still, very, very useful to do something like this. I love this. Now I'll just do console log this, console log, and call it a day. That to me is brilliant. And so on that subject, the class syntax kind of takes a key from this. If I want to make a class, notice in my class pizza, I got my constructor, but I'm not doing constructor colon function blah blah blah. I'm just doing constructor. So that again is this new class syntax, and combined sort of with the same approach that you're taking with object literals. Just by giving the name of that function, it assumes that I mean that it should be a function and that it's the constructor, and so I don't have to do anything extra for that. I can do the same thing with other methods. So if I have a method called eat, I'll just do it like that. It knows what I mean by that. Let's say, what else can I do with pizza? I can slice it. And so it's important to note that this is just syntactical sugar. At the end of the day, what you're getting back is still a prototype, right? So notice that this thing says function pizza. This is still a pizza prototype. It's not a real class. It's still the same old classes we've always been using in JavaScript. The only difference is that it's much nicer to write. It's much nicer to write, especially if you're coming from the back end where you have a lot of these object-oriented languages that have specific syntax for classes. This is a lot nicer. So even though this is just syntactical sugar, what's really important about this is that this is going to lower the bar to be able to write JavaScript in a nice and pleasant way. So this is going to get more people that did the backend get more excited about JavaScript to write more JavaScript. So we're going to see a lot more backend developers contributing to more JavaScript things because of nice syntactic sugar features like this. Now the other thing that it does is that it makes this whole constructor business more explicit. So there's a function called constructor. Yeah.
Can you extend class?
Yeah, you can. So that's another thing I was going to mention is that it makes it really easy to extend a class. So let's say I have an extra large pizza that extends pizza. That works. And it also sets conventions about how you should treat the superclass. So before you'd have to kind of make that up by yourself. You have to Google it and say like, okay, where should I put the constructor? How do I call the constructor's function if I need it? Maybe you have to have a reference to the old class. With the new class syntax, it takes care of all that for you. It gives you an opinion on how that should work. And so in the end, you get a much nicer object-oriented experience.
But you can only extend one class, right?
What's that?
You can extend one class only, right?
To my knowledge, you can only extend one class. I haven't actually pushed the limits of that. So actually, I'm going to get closer to that. There you go.
Thank you.
So you can only extend one class with the syntax, but you can still mix in other classes like you always did in JavaScript. So you can have, like, you can call, like in the constructor for pizza, I can call the 3 different classes constructors, and they'll set up their stuff on there too. That's weird though. Does not necessarily work out. Okay, so classes is really cool. Pretty straightforward. I'm not going to spend too much time on those. Right. Object letters did that, template did that. So I'm going to skip assignment destruction because that will blow your mind. But I'll go directly to let and const, and if I have time, I'll go back to assignment destruction. So let and const are basically fixed versions of the var keyword. So let and a variable this will work, pizza will work just like a normal variable. The only difference is that it's block scoped instead of function scoped. So if I do let pizza inside an if, outside the if, that variable's gone. So it's block scoped, and this is something that really trips up a lot of people when they're first writing JavaScript. Like, oh, I did var here, like what's going on here? Like, and with the hoisting and all that craziness, this fixes all that. So mostly you should pretty much be using let unless you're explicitly trying to take advantage of the function scoping rather than block scoping. So most of the time let will work exactly the way you're expecting and not do anything weird. Okay? So just to exemplify that, if I do if true let other pizza equal Hawaiian, I don't know how to spell Hawaiian. Hawaiian pizza? I think that's right, okay? It's not, hopefully there's nobody Hawaiian in here. So now if I do other pizza, nope, not defined. Because that is defined in the scope of that block. So in a for loop, this let is going to limit that variable to that one iteration of the for loop. In an if, it's going to only be working that if, and obviously in the function it's also a block. But so this will not bleed out into the outside world. Whereas if I did var on this, it would work, right? I would be able to use it. On that same subject, there's also const. Let me clear this out. Clear out this crap. There's also const, which is also block scoped, and you can use it just like you do with every other variable. Here's the only issue with const. It works exactly the same as a regular variable, except you cannot redefine it. So I better be sure that I wanted a pepperoni pizza because now that's all I have. I can't change this to a mushroom pizza. So it said, oh yeah, everything went great, but look, if I do pizza, it's still pepperoni pizza. So no reassignments for constant variables. Now don't confuse that with real immutable values. Like if I assign const obj to an object, and I do object dot something, that object is still mutable. It's still changeable. Arrays and objects are both still changeable even though you do it with a constant. This only prevents you from literally doing obj equal array or something. So even though say, oh yeah, it worked. Obj is still the original object. Okay? So it prevents you from reassigning, not from mutating the values. But a lot of values in JavaScript are immutable. Strings are immutable. Anything you do to a string, it's going to return a new string with the changes made. So strings are immutable, numbers are immutable, booleans are immutable, arrays and objects are not. Arrays and objects can change over time, and const does not prevent you from doing that. Okay, cool stuff. So,
can you set an object property to be constant?
I don't think you can. Well, one thing I forgot to mention about the class syntax is that you can set static functions. So like class, quote unquote class functions, you can set that easily in class too. But no, there's nothing like there's not a syntax for saying this property is now immutable. There is methods on objects that let you do that. So there's a way to like say this property is like read-only, or there's also a way to like lock down the entire object. Say this object, it's called object.freeze. This object, I would demonstrate it, but I actually haven't used it, so I don't know exactly how it works. But object.freeze, essentially what it does is that it takes the properties in that current object and makes them unchangeable. I read somewhere that there might be some way to get around that, but I can't remember. So actually I don't have time for destructuring, so I'm not going to do it. So really quickly, there are many, many more features that you can check out on ponyfood.com. This man, his name is Nicolas de Vacqua, he's Argentinian. He's giving talks all over the place. He spoke at JSConf, I believe. And so he's made a lot of really in-depth articles about ES6 that are really, really good. Check that out. I'll have this and many other links in a link I'll show you at the end. And so, to close, this is really exciting. New JavaScript every year, compared to 10-year gap. That's crazy. And I can use today's JavaScript right now immediately because tools like Babel are keeping themselves up to date way faster than browsers can update themselves. And new features are pouring in, and they're really, really cool. And I think this means that a lot more people are going to be writing JavaScript. And that's, to me, that's really, really exciting. So I hope you enjoy your JavaScript adventure. And I'd like to take a couple minutes to plug something. So I've been Nizar Khalifa Iglesias. I'm Puerto Rican originally. I've been a web developer for about 8 years. I've been here in Miami for 3 years, so I'm actually a local. And you can follow me pretty much anywhere at my last name and my first name, which is in the slide, so I won't expect you to remember that. That used to be me until I shaved. So I'm the lead instructor at IronHack. I'm the lead instructor at IronHack, and IronHack is a coding boot camp here in Miami. Oh boy, that was crazy. And so we teach beginners how to code. Every 2 months, I get a group of people like this, and some of them are beginners, some of them are computer science majors, some of them are college dropouts. There's a mix. They all have one thing in common. They're all trying to learn how to code. And so I spent 2 months with them, trying to teach them the fundamentals of web development. And oh, by the way, this guy right here, this was me like 3 weeks ago. Can I zoom in? Wait, yeah, zoom in. That's yep.
Great.
Anyway, so we're looking for mentors to help these students on their journey. Every 2 months, we're pumping out new web developers that have have very little experience and they need help. They need help along the way. So I'd like some of you to become a mentor if you're local. I know a lot of you are coming out from out of town, but being a mentor is a 4-hour commitment across 2 weeks. Those 2 weeks are the 2 weeks they're spending making their final project. That's their first web application that they wanted to make that they're making from scratch. And so they need help. If you want to pay it forward, talk to me and apply to be a mentor.
Do you have a sign-up sheet or something for that?
I don't have a sign-up sheet, but I'm the sign-up sheet. So just come talk to me and I'll sign you up. Okay? So that has been the present and future of JavaScript, ES2015 and beyond. I hope you enjoyed that. Thank you so much for being patient with me. And this tiny little thing, which I'll zoom in on so you can see, is a link which is currently empty, but eventually it will contain a lot of really cool resources, including my slides. So you can continue learning about ES2015 and all the ES20X until from now until the end of time. Okay? So bit.ly UX+DEV -ES2015. Thank you so much, guys.